Okay, we're going to start with the polynomials in Chapter 4. Integers as exponents. We're going to tell the meaning of exponential notation, the value of exponential expressions, evaluate algebraic expressions containing exponents, use the product rule to multiply exponential expressions with like bases, use the quotient rule to divide exponential expressions with like bases, and express an exponential expression involving the negative exponents with positive exponents. When you're looking at exponents, in this case, a would be considered the base, and 4 is the exponent, and that tells us how many times we're going to multiply the factor. So the exponent is 4, the base is a. An expression of a power is called exponential notation. An example, what is the meaning of 4 to the 5th? And also, what is the meaning of 3n raised to the 3rd? Basically, it says that we're going to write 4 times 4 times 4 times 4 times 4. We're going to write it down 5 times. And then the 3n raised to the 3rd, simply saying 3n times 3n times 3n. So for any exponents of 0 and 1, a raised to the first power is simply a, but anything raised to the 0 power is 1. So for example, if we evaluate these, 6 raised to the first is going to be 6. Negative 4 raised to the first is still negative 4. 5 raised to the 0 power is 1. And then negative 8.2 raised to the 0 power is still just 1. We're going to evaluate, and again, the word evaluate means to find a value or a number. So we're going to plug in. So 500 minus 3 raised to the 5th power equals 500 minus 3 raised to the 5th power, which is 243, which simply equals 257. Again, we're going to evaluate this. So you have 6 times negative 3, all raised to the 3rd power. So 6 times negative 3 equals negative 18 raised to the 3rd power. Again, anytime you have an odd power and a negative number in the inside that's been raised, your answer is going to be negative. So negative 18 raised to the 3rd power is negative 5,832. Now this one's a little bit different. I want you to notice something. That 6 is not in parentheses, just that 3. So we're going to say this right here. We're just raising the negative 3 to a power. So that's going to be 6 times a negative 27, which is going to equal a negative 162. There are several rules for manipulating exponential notation to obtain equivalent expressions. Multiplying powers with like bases is one of them. If they have a like base, then you simply just add the exponents. Okay? We're just going to add the exponents. And that's all this slide is saying. It's called the product rule. If they have the same base, you just add the exponents. So a becomes x to the 8th. B becomes 6 to the 12th. Because when you add them all, 2 plus 7 is 9, plus 3 is 12. And then when you're looking at this one, remember there's an understood 1 here. So this becomes x to the 16th. And then the last one is w to the 6th and z to the 11th. Now when you're having division, you just take the smallest exponent to the largest and you subtract if they have like bases. So in this particular case, 8 raised to the 7th power is going to be 8 raised to the 7th power minus 3, because we're subtracting exponents this time. So that becomes 8 to the 4th. B becomes x to the 6th. C becomes y to the 8th. And then D, we have the r and the t, so it becomes r to the 4th and t to the 8th. Remember, if it doesn't have one listed there, it's really there. Right? When you can't, just like in English class, you have etiquette, you have to cross your T's, dot your I's, and so forth. So you can't have negative exponents. So you just bring them to the bottom if they're already in the top, and if they're in the bottom, you bring them to the top. You're just going to change them. So this becomes 1m over 5. B becomes 5 raised to the 2nd power, and that simplifies to 1 over 25. And then C becomes 1 negative 4th squared, and that becomes 1 over 16. And then this one, x stays the same because it doesn't have a negative exponent, but the y goes to the bottom, and you can leave it as y to the first, or simply just x over y. Now, we do not leave negative exponents in the answer. So if you see that, you need to change it. Here's the trick. Take the largest to the smallest and you subtract. Okay? Now remember, in this case, you can just add them if they're being multiplied. So this becomes w to the 2nd. This one becomes b raised to the positive 9th power. Now what's smaller, negative 5 or negative 6? Remember this, the further away you get to the further away on the left hand side you get from 0, the smaller your number gets. So negative 6 is going to be your small one. So this becomes a negative 5 minus a negative 6. So that becomes a negative 5 plus 6, and that becomes a to the 1st. And again, this slide is simply just your rules. Good luck.